You're floating, not swimming, floating, in the middle of the South Pacific Ocean, on a surface so flat it looks rendered. The water beneath you is the color of deep indigo at the edges and pure black directly below. You can't see the bottom. The bottom is 4 kilometers down. And the closest humans to you right now, the closest living people anywhere on this planet, are not on any shore, not on any ship, not on any island. The closest humans are not on land. They're in space, orbiting at 400 kilometers above your head, moving so fast they'll pass over you and be gone before you finish this sentence. You are standing at the most isolated point on the surface of the Earth, and under your feet, resting somewhere in the silt and the dark, are the ruins of over 263 spacecraft. This is Point Nemo, and in 2030, the largest spacecraft ever built is going to fall here. The question isn't whether it'll survive the fall. It won't. The question is what we're really burying when it hits the water. Let's start with the geography, because the geography itself is almost too strange to believe. The coordinates are 48 degrees, 52.6 minutes south latitude, and 123 degrees, 23.6 minutes west longitude. If you dropped a pin there on a map, you'd be staring at an almost perfectly empty circle of ocean. No land visible in any direction. The nearest coastline, Ducie Island, part of the Pitcairn Islands, is 2,688 kilometers away. In the other direction, the nearest land is Easter Island. To the south, it's the coast of Antarctica. Every direction you look from that point is water and more water, for distances that break your sense of scale. To put it another way, if you stood at Point Nemo and started walking in any direction at all, you would travel farther before reaching land than the distance from New York City to Los Angeles, twice. This isn't just remote. This is a different category of remote, a place so far from everything that the concept of distance from civilization doesn't quite cover it. The word for what this place is, the technical term, is the oceanic pole of inaccessibility, the single point in any ocean that is farthest from any coastline. And for the South Pacific, which is the largest ocean on Earth, that point is here. The International Space Station orbits at roughly 408 kilometers altitude. That sounds high. It is high, but it's not as far as you might think. If you drove a car at highway speed directly upward, you'd reach the ISS in about 4 hours. Distance-wise, it's closer to you than many major cities are to each other. And because the ISS travels in a roughly inclined orbit, covering latitudes between 51.6 degrees north and south, it regularly passes directly over Point Nemo. When it does, the 6 or 7 astronauts aboard become, for a few minutes, the closest humans to this patch of ocean, closer than anyone on any ship, closer than any fisherman anywhere. There are people alive right now who have never been within 1,000 kilometers of Point Nemo. There are people who've spent their entire lives in the most densely populated cities on Earth and never given this place a single thought. And yet, quietly, over the last 3 decades, it has become the final resting place of more spacecraft than anywhere else on Earth. Why here? The answer is simple, but it carries weight. You need a place to bury your spacecraft that won't land on anyone, that won't hit a ship, that won't crash into a coastline, that won't scatter debris over a populated area. And Point Nemo satisfies all of those conditions better than any other point on this planet. It's not a graveyard because anyone chose it for its symbolism. It's a graveyard because the math led here. The cold, clean math of trajectory and distance led every space agency on Earth to this one spot. The name has a story, Point Nemo. Nemo, from the Latin, nobody. It's also a name pulled from a Jules Verne novel, the famous Captain Nemo, who commanded the Nautilus and sailed the ocean's deepest depths in 20,000 leagues under the sea. Verne's Captain Nemo was a man who had turned his back on human civilization entirely, a ghost, a man of nowhere. It's a perfect name for a place that is, literally, nowhere. The point was formally calculated in 1992 by a survey engineer named Harvey Lucatella. He wasn't a sailor or an explorer. He was a Croatian-Canadian computer scientist who used a specialized geodesy software program to identify the exact coordinates of the oceanic pole of inaccessibility. He wasn't looking for something dramatic. He was doing spatial geometry. He didn't know he was naming a graveyard, but within a decade of Lucatella's calculation being published, space agencies already knew exactly what this discovery meant for them. Since the dawn of the space age in 1957, humanity had been launching objects into orbit with essentially no plan for what happened when those objects came down. The early years were chaotic. Sputnik burned up on re-entry in January 1958. Vostok capsules were recovered. Early American satellites simply decayed from orbit and disintegrated. But as the objects got bigger, as stations grew larger, as cargo ships grew heavier, as the era of modular orbital infrastructure arrived, the question became unavoidable. Where do you put something the size of a building when it falls from space? You can't control where debris lands with perfect precision. A spacecraft re-entering the atmosphere at hypersonic speed is being torn apart by forces beyond easy imagination. It's not like landing a plane. It's like firing a bullet into a furnace and then trying to predict exactly where the fragments land. The math can get you close, within a corridor, within a window, but not to a pinpoint. So the answer was, put it somewhere where being off by a few hundred kilometers doesn't matter. Put it somewhere there's nothing. Put it at the farthest point from everything. Put it at Point Nemo. The first deliberate use of the Point Nemo corridor for controlled re-entry happened in the late 1970s with Soviet spacecraft. By the mid-1990s, it had become informal international practice. By the 2000s, it was operational doctrine. And by now, in 2026, a stretch of ocean floor roughly 1,500 kilometers across and centered on those coordinates holds the physical remains of more than 263 machines. Machines that were once, some of them, the most sophisticated objects humans had ever built. But the geography, the math, the cold practicality of why this place exists, that wasn't the whole story. Because the most important object ever buried here wasn't just a machine, it was a home. 263 machines sleep below. Most of them are relatively small. Progress cargo vehicles, Russian resupply ships roughly the size of a large van, used to carry fuel and food and equipment to orbital stations. They complete their missions, get packed with trash, and then deorbit deliberately into the South Pacific. A few hundred kilograms of hardware, mostly burned to nothing on re-entry, the surviving chunks swallowed by the ocean. Clean, efficient, invisible. Then there are the larger pieces. ESA's automated transfer vehicles, the Jules Verne, the Johannes Kepler, the Edoardo Amaldi, the Albert Einstein, the Georges Lemaitre. European cargo vessels roughly 10 meters long and 4.5 meters in diameter, each weighing nearly 20 metric tons at launch. All 5 of them now lie somewhere in the Point Nemo corridor, sent there between 2008 and 2015 after completing their missions to the ISS. Japan's HTV vehicles, H2 transfer vehicles, called Konotori, meaning white stork, 9 of them flew between 2009 and 2020. All 9 came here to die, each one roughly the size of a city bus, each one intentionally burned from above and shattered from within and deposited here, in this empty ocean with no monument and no ceremony. There are also pieces that weren't supposed to land here, parts of rockets, structural components that survived re-entry when engineers expected them to burn, a section of a Soyuz station, fragments of unmanned Soviet vehicles whose official designations are buried in Cold War archives. The ocean floor here is not uniform. It's not a neat grid of wreckage. It's more like a corridor, a long diagonal swath where orbital mechanics and atmospheric drag intersect. The debris field stretches for thousands of kilometers. Some pieces are intact. Most are fragments. A few are unrecoverable, dissolved, corroded, scattered by bottom currents over years and decades. No one has ever dived to see it. The depth makes it essentially impossible for any current manned submersible program to survey comprehensively. The ocean floor at Point Nemo varies between 3,000 and 4,000 meters. At those depths, the pressure is roughly 400 atmospheres, 400 times the pressure you feel on the surface. Even remotely operated vehicles have limited reach. Point Nemo's spacecraft graveyard remains for practical purposes unseen. We know what's there only because we put it there. But let me tell you about Mir, because Mir was not just a station. It was a city. It launched in February 1986 at the height of Soviet power. The core module, called DOS-7, went up on February 19, 1986, and became the first module of what would grow over 15 years into a 6-module, 130 metric ton orbital complex. The name in Russian means both peace and world. It was, in its time, the most complex machine humans had ever operated continuously in space. Think about what Mir actually was for a moment. Over its operational life, 104 cosmonauts and 7 astronauts visited. It hosted crew after crew after crew through 3 separate eras of history: Soviet Union, collapse of the Soviet Union, the Russian Federation. Valery Polyakov lived aboard Mir for 437 consecutive days beginning in January 1994, completing the longest single spaceflight in human history at the time, a record he held for nearly 2 decades. He came back to Earth on March 22, 1995, and could barely walk. His body had adapted to weightlessness so completely that he had to relearn what it meant to stand. Shannon Lucid, an American astronaut, lived on Mir for 188 days in 1996, the longest U.S. spaceflight at the time. When she landed, the first thing she wanted, she later said, was M&Ms. She'd been dreaming about M&Ms for 6 months. After nearly half a year of dehydrated food and foil pouches, the thought of something that just tasted like Earth, like candy, like color, like normalcy, was what her mind returned to. This is what Mir was, not a machine. A place where humans adapted and craved and laughed and endured. A place where people counted days, dreamed of food, grew gardens of wheat and lettuce in a module called Priroda. A place where a cosmonaut's home address was, legitimately, technically, outer space. By the late 1990s, Mir was aging badly. The station had been designed for a 5-year operational life. It ran for 15. The systems were degrading. Oxygen generators failed. Water recyclers leaked. A dangerous collision with a Progress resupply ship in June 1997, the result of a botched manual docking experiment, punched a hole in the Spectre module and came within minutes of killing the crew. Cosmonaut Vasily Tsiblyev was at the controls. The ship drifted. He tried to abort. The collision was unavoidable. The crew, Tsiblyev, Alexandra Lazutkin, and NASA astronaut Michael Foale, had roughly 12 to 14 minutes before the station's atmospheric integrity would fail catastrophically. They sealed the hatch to Spectre. They stopped the pressure drop. They survived. But Spectre was dead, and Mir was wounded in ways that couldn't be fully repaired. Michael Foale later described the minutes after the collision with extraordinary calm. There was a slow leak, he said, and I remember thinking, this is manageable. We can manage this. And then I thought, what if we can't? He used the back of his hand to feel air movement in the station, the old cosmonaut trick, to find which direction the leak was pulling air toward. It was pulling toward Spectre. The hatch was sealed, the crisis was contained. But the crisis on Mir was never really contained after that, not fully. The station's reputation was damaged. Its systems continued to degrade. A fire in the KVANT-1 module, caused by a failed oxygen generating canister, had already scared crews in February 1997. A computer crash knocked out orientation control. Power systems fluctuated dangerously. By 1999, the decision had been made. Russia couldn't afford to maintain Mir indefinitely. The new International Space Station was coming online. Mir had to go. And that's when the most controlled act of destruction in the history of spaceflight began. March 23, 2001, 0:59 Coordinated Universal Time. The command is sent from the Russian Mission Control Center in Korolev, outside Moscow. A final burn from Progress M15, the last resupply ship docked to Mir's aft port. The burn lasts 22 minutes and 4 seconds. It's not a violent command, it's a subtraction, a gentle removal of velocity, just enough to drop Mir's perigee, the lowest point of its orbit, below the threshold where atmospheric drag takes over. Mir begins to fall. At 5:44 Coordinated Universal Time, the station makes its final pass over Europe. People with telescopes watch it crossing the night sky. A bright point of light, brighter than usual, visibly lower than it should be, moving with a speed that looks almost normal until you realize it's descending, that it's coming down, that it isn't going to come back around. At 5:52 Coordinated Universal Time, Mir enters the atmosphere at a velocity of approximately 7.7 kilometers per second to 27,720 kilometers per hour. It's traveling fast enough that in the time it takes to read this sentence, it has moved 35 kilometers through the sky. The ablation begins at roughly 100 kilometers altitude. The outer surfaces of Mir, panels, struts, antennas, the fragile outer skin of modules begin to vaporize. The friction isn't like rubbing your hands together, it's plasma. Temperatures at the bow shock reach 1,600 degrees Celsius. Metal doesn't melt at those temperatures. It ignites, it burns, it becomes light. The station doesn't fall in one piece. It was never going to. At some point between 80 and 70 kilometers altitude, no one knows the exact altitude because no instrument survived to record it, the structural stresses exceed what any weld or bolt can hold, and Mir breaks apart. The core module, the quant modules, the crystal module, the Pryrota module, the spectre module, they separate. Each piece follows slightly different trajectories depending on its mass and drag profile. Each piece burns at its own rate. Witnesses on ships in the South Pacific, positioned deliberately to observe the re-entry, reported seeing a stream of fire across the sky. Not a single fireball, a train. A scattered constellation of burning fragments, each one trailing light, spread across roughly 1,500 kilometers of sky. Like a meteor shower made of history. Witness accounts from Fiji described it as beautiful. One report from a commercial aircraft, Flight NZ052, a New Zealand-bound passenger flight whose crew had been briefed to watch for Mir, described the event over the intercom to passengers. The crew reportedly said, "Ladies and gentlemen, if you look out the windows on the right side of the aircraft, you'll see the end of the Mir space station." Most of Mir burned, not all of it. Calculations suggested that between 1,500 and 2,700 individual fragments would survive re-entry. Heat-shielded components, dense metal masses, structural hardware too solid to fully vaporize. These fragments, traveling at supersonic speeds but no longer burning, splashed down in the South Pacific between 40 and 60 degrees south latitude, 160 degrees west longitude. The target corridor, the Point Nemo zone. No human being has ever seen those fragments since. The ocean closed over them within seconds. The South Pacific absorbed 130 metric tons of Soviet history, 15 years of human presence in orbit, the greenhouse where wheat grew in zero gravity, the walls that bore the handprints of 111 people who lived there, absorbed all of it without a ripple visible from the surface. Mir was dead. And for a few days, there was mourning, real mourning. Cosmonauts who had lived aboard Mir were asked how they felt. Alexander Lazutkin, who had been aboard during the collision, said, "Mir was home. When you live in a place, it becomes part of you. When it's gone, something that was part of you is gone too." Viktor Blagov, the deputy flight director who oversaw the deorbit, reportedly wept when the confirmation came through that Mir had impacted the target area. This is the part that doesn't appear in the orbital mechanics textbooks, the part about what it costs emotionally to destroy something that people lived inside. The part about the Russian engineers who had dedicated decades to Mir, watching it become a light show over the Pacific. The cold math of trajectory and distance doesn't capture that, but it's true. It happened. And it's waiting, under 4 kilometers of water, right now. But the story gets even larger. Because what fell into the ocean in 2001 was roughly 130 metric tons. What's scheduled to fall in 2030 weighs 450 metric tons. Let's talk about what's coming. The International Space Station is the most expensive single object ever constructed by human civilization. The total cost, across all partner nations, the United States, Russia, Europe, Japan, and Canada, exceeds $150 billion. In inflation-adjusted terms, it cost more than the Manhattan Project, more than the Apollo program. It is, by that metric, the most expensive thing humanity has ever made. It is also, by most engineering assessments, dying. The ISS launched its first module, the Russian-built Zarya control module, on November 20th, 1998. Since then, over 230 people from 19 countries have lived aboard it. Over 3,000 scientific experiments have been conducted in its laboratories. It's been continuously occupied since November 2nd, 2000. Right now, tonight, there are human beings living inside it. but the station was designed for an operational life of roughly 15 years. It is now, in 2026, 28 years old. Components are showing signs of stress that were not anticipated in original design documents. The Russian Zvezda module, the functional backbone of the ISS's service systems, has developed multiple small leaks in recent years, cracks in the hull that engineers have been patching and monitoring with increasing concern. Russian cosmonaut Anatoly Ivanishin noted in documentation from 2021 that some cracks were developing faster than expected and that monitoring had become a constant routine. NASA's own assessment documents, released in 2022, identified that extending ISS operations beyond 2030 would carry significant structural risk. The agency concluded that a controlled deorbit before the station's systems began failing spontaneously was not just preferable, it was necessary. So, the timeline was set, the target was announced, and the target is exactly where you'd expect it to be. NASA has contracted with SpaceX to build a dedicated deorbit vehicle, the U.S. Deorbit Vehicle, USDV, specifically to bring the ISS down safely. The contract, worth up to $843 million, was awarded in June 2024. The mission profile calls for the deorbit spacecraft to dock with the ISS, provide the necessary propulsion for a controlled descent, and guide the station's remains into the South Pacific Ocean disposal corridor. The target coordinates, the Point Nemo zone. Think about the scale of what this means for a moment. Mir, at 130 metric tons, was described by observers as producing a train of fire across 1,500 kilometers of sky. The ISS, at 450 metric tons and measuring 109 meters from end to end, longer than a football field, will produce something categorically different. Engineers estimate that between 20 and 25% of the ISS's mass could survive re-entry and impact the water. That's between 90 and 119 metric tons of hardware striking the South Pacific at speeds between 250 and 500 kilometers per hour at water impact. The fragments that survive will be large. Some could be the size of cars. Some could be the size of rooms. The pressurized modules, the Columbus Laboratory, the Destiny Laboratory, the Harmony node, are dense, reinforced structures. They won't all burn. The impact zone will need to be restricted to maritime traffic for safety. The debris field could stretch hundreds of kilometers, and when the last fragment sinks, when the surface of the South Pacific closes over the last piece of a structure where 273 people once lived and worked and discovered things about the universe, it will be over. The station that has been continuously occupied for 25 years will be gone. There's a question that isn't asked very often in the technical documents. What do we owe to the places where people lived? Point Nemo has never been a formal memorial. It has no marker. No GPS beacon on the surface says, here is where Mir fell. No buoy marks the approximate resting place of the automated transfer vehicles or the progress ships or any of the cargo vessels sent there over 3 decades. The ocean keeps no record, but the ocean floor does. Deep-sea researchers have noted that the oxygen content at the depths where these spacecraft rest is extremely low. Microbial life in these areas is limited. Metal degrades slowly in these conditions. Some pieces could theoretically persist for centuries before fully corroding. This means that the debris field at Point Nemo is not disappearing. It is accumulating. It is growing, slowly, decade by decade, as more objects are directed here. Some researchers have proposed that the site should eventually be designated an archaeological zone, an underwater heritage site representing a specific chapter of human technological history. The argument is not absurd. We designate terrestrial crash sites as heritage locations. We protect sunken naval vessels under maritime law. The machinery at Point Nemo is arguably as historically significant as any of them. There's something strange and beautiful and sad about the idea that future generations, centuries from now, when deep-sea exploration technology has advanced enough to actually reach these depths efficiently, might be able to descend to Point Nemo and see it, see the fragments of Mir, the pieces of the Jules Verne ATV, eventually the ruins of the ISS. Imagine what that would look like. The wreckage of everything humanity sent into orbit, gathered in one place by the geometry of the planet. A museum of departure. It's 2026, and Point Nemo is busier than it's ever been. The number of objects being sent to orbit has increased exponentially in the last decade. SpaceX, with its Starlink constellation, is launching hundreds of satellites annually. Amazon's Project Cooper is following suit. Space agencies from China, India, Europe, and Japan are all expanding their orbital programs. The era of commercial space is producing hardware at a rate the Cold War programs never imagined, which means the question of what to do with all that hardware when it stops working is becoming urgent in ways it wasn't before. Not everything comes down to Point Nemo. Small satellites, under a certain mass threshold, are designed to deorbit in orbits low enough that atmospheric drag will bring them down within a few years, burning completely on re-entry with nothing reaching the surface. But larger hardware, cargo ships, upper stages, anything above a few thousand kilograms, needs a controlled disposal, and the destination is almost always the South Pacific. The corridor is getting crowded, in a cosmic sense. There's also the environmental conversation.
The Point Nemo disposal site sits in what's often called the South Pacific Gyre, a vast rotating ocean current that tends to concentrate rather than disperse anything that enters it. Research published in 2023 raised questions about the long-term impact of spacecraft re-entry on atmospheric chemistry. The metals and compounds vaporized during descent create traces that, at current volumes, are measurable in the stratosphere. Aluminum oxide from burning spacecraft has been detected in particulate sampling at altitudes between 40 and 60 kilometers. Right now, those concentrations are low, but the trajectory, the increasing frequency of re-entries, is a trend line that climate researchers are beginning to take seriously. The graveyard has an atmosphere. On the ground, or rather in the water, the 2030 ISS deorbit planning is ongoing. NASA and its international partners are coordinating the most complex controlled re-entry ever attempted. The logistics involve not just the trajectory of the station itself, but the coordinated deorbit of partner nation components, the removal of valuable hardware before entry, the management of hazardous materials, and the coordination with maritime authorities to clear the impact corridor. SpaceX's deorbit vehicle, if everything proceeds on schedule, will dock with the ISS in the late 2020s and execute a series of phased deorbit burns stretching over months, slowly lowering the station's orbit until atmospheric drag takes over. The final burn will be the most precise orbital maneuver ever conducted for a deorbit mission. The margin for error on the impact corridor is measured in kilometers. The stakes of getting it wrong, even slightly, would be significant. And when it's done, when the last piece of the ISS sinks below the surface of the South Pacific, humanity will have retired its last continuously occupied orbital outpost. The era of the ISS will be over. A quarter century of permanent human presence in space, of people always being up there, of the number of humans alive on Earth plus a handful, always being larger than the number alive just on Earth. That era will require a successor to continue. The successors are being built. NASA's Commercial Low Earth Orbit Destinations program is funding private stations. Axiom Space is attaching its own modules to the ISS right now, with the plan to eventually detach them and form the nucleus of an independent station. The Chinese space station, Tiangong, is operational and expanding. There are plans, there are always plans, but there will be a moment, sometime in the 2030s, when the ISS is gone and its replacement isn't quite ready, when the continuous chain of human habitation in space, a chain that has run unbroken since November 2nd, 2000, will have to be preserved by something, or it will break. That's the question no one in the press releases quite asks directly. You're still standing on that ocean surface now, or imagine it. Close your eyes and imagine it. The surface of the South Pacific at Point Nemo. No land visible, no ships, no sound except the water and the wind and the nothing. Overhead, if you're lucky, the slight shimmer of a bright point of light crossing faster than any star. The ISS, or its successor, carrying people in its belly. People who right now are the closest human beings to you on this planet. Below you, somewhere in the dark, pieces of Mir are resting on the seafloor. The greenhouse where Valery Polyakov grew wheat during his 437-day mission. The module where Michael Foale felt for the direction of the air leak with the back of his hand. The medal that cosmonaut Viktor Blagov wept over when it was gone. All of it down there, unseen, undisturbed. Here is what I think about sometimes. Every spacecraft that fell here was, for a moment, the highest expression of human engineering. The most sophisticated thing our species had figured out how to build. And then it came down. Not because it failed, because it finished, because the math required it.
because there was a place on Earth remote enough to receive it without harm. The ocean accepted all of it, without ceremony, without objection. The same water that has been on this planet for 4 billion years, that has never seen a human being except from far below, that has no memory and no opinion, it just took what we sent and held it. We are a species that reaches up and then, eventually, falls. And there is something in the fact that our falling place is also the place where no one is, the place farthest from all of us as far as this round Earth allows, that feels like something more than accident. Like we were trying, even in the act of discarding, to send it somewhere worthy of what it had been. In 2030, the ISS will fall here, and if you were standing on that ocean surface when it comes down, you would see it. A train of fire crossing 1,500 kilometers of night sky. Metal that once held sleeping quarters and laboratories and observation windows where 273 people watched the curve of the Earth below them becoming light, becoming heat, becoming nothing. And then the South Pacific will close over it the way it always does, and the surface will be flat and dark and empty again. And the closest humans to that place will still be overhead, still up there, still looking down.